For today, to start us off, we're going to take a look at this system of equations, and we want to solve it by substitution. So this will be our lab exercise, and we'll have you write this down, and I'll give you the first step, which will be solve one of the equations for one letter. And it's obvious that we would solve it for y. How about x? Yes, let's solve it for x. So x would then equal, we just transpose that, a negative 6y plus 2. So this is what we have. We're now going to put this value for x where x is in the other equation, and then you'll have just the letter y that you will then solve. All right, we'll give you some time to work on that. So then we took this value for x, brought it to our other equation where the x is, and substituted, and that's where it gets its name from. Now we have just one equation with just y's. So we clear parentheses, a negative 24y plus 8 plus 5y equals a negative 11. And again, go back frequently and check your work. Check your signs. Be sure you're not making a little error somewhere. Now we're going to group like terms, and we get a negative 19y. Grouping our like terms, we're going to transpose this to the other side. On this side it becomes a negative 8, or subtract 8 from both sides. And now we're going to divide both sides by a negative 19. We get y equals a 1. Well, that's one member of our ordered pair, which is the y. We need to find the x. Well, if we go up here, we see that x is this. So we put our 1 where the y is. This becomes a negative 6 then, plus 2, gives us a negative 4 as our ordered pair. Now, what we just did is to do this equation, or system of equations, by substitution, where we solve for the letter x. But we also know we could use elimination. And we do so, and this is what we'll show, because I want you now to do this one through elimination. And to get you started, as we look at these two systems of equations, if we added them up, nothing would cancel out. But if I were to multiply each term in this equation by a negative 4, that is, make this an equivalent equation in which this term became a negative 4, adding these columns together would cancel out my x's. So the strategy is to rewrite it. This then becomes a negative 4x. This becomes a negative 24y. And this becomes a negative 8. So I'm just taking this negative 4 and multiplying it by each term. And now I just copy this second equation down, which is 4x plus 5y equals a negative 11. And I'm writing big so you could see it, but I'm running out of room a little bit, but that's okay. So now, when I put my line and I add up my like terms, here the x's cancel out, and here I'm left with a negative 19y equals a negative 19. So, again, I divide both sides by a negative 19. I get y equals 1, and that's what we had earlier, that y is 1. Notice the other time, well, this is how we did it, yes. Sometimes we might have reversed letters, but not here. So now, if we know that y is 1, we have to go back to our original equation. So we have x plus y is 1, so this is going to become a 6, equals 2. And subtracting 6 from each side, x is equal to a negative 4. So we've used two methods of algebra using the same system of equations, and notice we get the same answer. So theoretically, sometimes using substitution would be the easier way, and sometimes you can't use substitution, so you have to use this elimination, which is sometimes called the addition method. Okay, so hopefully you've had some hands-on and were able to explain this to a colleague.